Yesterday, we created the one table called employee, and we created the table and we loaded the some sample data. So these are the things we did. We created the table with the delimiter comma, and these are the sample data. And this is how we can load the data into table. And if we want to perform, if you want to run MapReduce program, we need to write the any select name from employee or select count from, like this. We need to write the queries. So today we will run it. Actually, while running yesterday, what is the issue means? I think before running that program, I think I changed this order master and slave. That's why sometimes it is we are running everything in VM. So that is there is a chance of changing the IP address. Sometimes maybe the IP address will be changed. So previously the slave one IP is 167, but the IP is now IP is 169 because of this IP conflict. So it is not reaching this IP address. So that's why only yesterday we are not able to run the MapReduce program through Hive. So now I changed the IP address to 169. Then we are able to uh, execute the MapReduce Hive. If you submit the Hive query, then automatically it will convert as a MapReduce job. We will see that one. Okay, show tables. Yesterday under default database, we created the user Hive warehouse. We created one table called employee and we loaded some sample data, employee.txt. So first we'll see what are the columns are there. For that one we need to type describe employee. So we have the four columns: ID, name, technology, and company. So we'll try to get the select name, comma company. Employee. So it will be converted as a MapReduce job. So once we submit the job, it will be so this job is submitted. Name is the select name, comma company from employee. So it will be automatically converted as a MapReduce job. It is completed. So whatever the previously how we executed the MapReduce program, once we submit the jar file, so how it is running. Same way, if we submit the any query for getting the some any fields from the table, or if you want to perform count star, if you want to perform any group by operation, like that, if you want to perform any computation operations, any transformations or any other operations, so it will be automatically converted as a MapReduce job based on the data. It will be converted as a mappers and reducers. It will execute similarly how we executed previously. So framework will take care about that one. So we don't need to bother about that one. So automatically it will convert. So we access for the name and the company. So these are the details. So like this, if you write any other query, select company star from employee. count star. So automatically it will convert as a map reduce job. Based on the data, it will convert as a number of mappers and number of reducers also. So this is we have the 4 records, so it is displaying 4 records. Okay, this is how we can create the table. So how we can create the table with the delimiter? How we can, if you have any sample data, how we can load the data? Once you loaded the data, it will be stored into whatever the HDFS path is there. So there it will be stored. So here it will be stored. So if you had one more table, if you have one more data also, it will be stored into same location. It will be stored. And if you want to write any queries, we can write like the select name from the employee or select any count star, select group, select name from employee, where condition or group by this condition we can perform. Okay, employee dot. I'm going to create one more table instead of employee dot txt. I'm going to create one more table. So here I'm changing the IP ID. Going to add one more record. Here I'm going to write some other data. So if we have like this, what will happen? We'll see. So if you have the more fields, uh, more comma separated values instead of 4 comma separated values. If you have the more values, what will happen? It will throw any error or simply it will load the data. So we will see that one. So for that one, we will simply copy this line. Instead of employee, we will give employee. So instead of employee, I am loading the employee1 txt. So how the data it is stored? So simply here one more file will add it. So in Hive tables, we can't insert the single row. We can't upload the single record. So we can upload the files, whatever the data is coming, we can load it to the table. Like this we can add it. So if we don't want, we need to delete the particular file. Like that only we can do. We can't insert, we can't update, we can delete this single row. We can do it in Hive. So Hive is a bulk processing tool. So we can load bulk amount of data and we can analyze the bulk amount of data. So if you will write this query, select star from employee. So if you observe here, we got the 10 records. So last column, why we got the null values? So if you observe here, so these are the 5 rows we have, and we have the one blank row. That's why only if you don't have data, or if you have only 2 columns, in that cases what will happen means whatever the comma separate values are there, it will shows the values. Other things it will be, will get as a null value. So for this record we don't have any data. So that's why each column we got as a null value. You observe this one like this. So if the data is there, then it will display. If extra data is also there, it will skip. Whatever the data we are specifying in Hive, so that part only it will take. Remaining things it will skip. So if the data is not there, so only if the data is there for only few columns, so whatever the data is there for the columns, it will display. Other columns it will simply show as a null value. So for this Hive, why the like this feature means, so input data we can provide any kind of data, maybe structured or unstructured. So data will be any kind of data. So from that, whatever the data we need to fetch, we need to specify that in the Hive. So input data it will be there. So Hive, what we need to specify means how for Hive we need to tell the how we need to fetch the data from the input data. So that thing we need to specify. So here what we are specifying means we need the 4 columns. So 4 columns data you need to fetch from the by using comma separated. So that data, that input data, we can have any number of comma separated values. So but first 4 things needs to be like a ID, name and company. Like that we need to arrange the data, input data. Other fields may be any kind of data. So instead of that format, so if the data, suppose instead of this one, suppose the first column may be ID, first comma separated field may be ID, second may be any some dummy data, second thing is the name, so other dummy data. Like that, if the data is there means, then we need to write the some custom logic to fetch the data. For that one we need to write the our own logic to fetch the data. So that thing I will tell later. So we can, for that we need to write the some in Hive we have the concept called SERD. So that is serialization and deserialization. We have concept called SERD. So from that we can write our own logic to fetch the. We can write our own regex also we can write. For that we have the one predefined regex SERD. So those things we will discuss later. While discussing about SERD, we can I will tell. So this is the how the data will fetch. So if you have extra columns, if you don't have the whatever the fields we needed, so Hive won't display any error. Simply whatever the data is there, so it will fetch the data. So this is the how you can load the data. How so if you perform select star from, simply whatever the data is there, simply it will display. It won't run the map reduce job. So whenever you are trying for the any particular fields or any if you are trying for any group by operation kind of thing, then only it will be displayed. Now I will try to perform on group by operation. Company, comma, count of company. group by company, and if you want we can perform order by company. If you observe this one, so previously, 1 minute, I think we will run after executing this one. I will explain clearly. While running the large queries, I will explain. Actually, okay. Here itself I will explain. Okay. So here if you observe, same query, it is running as a two MapReduce programs. So if you observe here, stage 1, stage 2, same query, but it is running as a two MapReduce. Why means? So one program it will perform the group by operations, one MapReduce program it will perform the order by. So that's why only it is executed under two same query, it is executed two MapReduce programs. But if you come to MapReduce program, we need to write the two MapReduce program, and we need to connect the first MapReduce output to the second MapReduce job. So here automatically it will change the jobs. So suppose if you write the big query with the group by, order by, and if you write the some multiple subqueries also, so in that cases automatically that complex big query it will convert as a multiple stages and it will run automatically. So sometimes we will get the stage 5 or 6 also will get based on the complexity of query, it will run as a multiple stages. So in stage 1 it will perform as a some group by operations. In stage 2 it will perform the order by operations. Like that it will be execute. So finally if you go to the terminal, so like this we will get output. So based on the we perform the order by operations also. That's why it will be ordered by the whatever we specified company name. Based on that one it will be ordered. So like this we will get the company and number of times the record is there. Like that we will get. So this is how we can perform the group by operations. Previously, I think in MapReduce program, if we want to group by, we need to write, we need to pass the as a key, and reducer we need to perform the that count or sum operations we need to perform. So here, instead of writing that complex query, we can execute in the simple query. We can execute. So this is how we can perform different operations. So group by, order by. And where conditions also, if you want to perform where conditions also, we can perform. Okay. Uh, that is about the sample query, how we can fetch the data. So yesterday we created one database called MyDB. So we'll use that DB and we'll perform the word count operations. Show tables. So yesterday we created one table called docs table. So in docs table, what we did means simply we loaded one Shakespeare file data into this table, docs table, and we have only one record. We created the table with this one. Only we have the one column words, and the table name is docs. So this based on this data, I'm going to perform the word count program. So if you want to perform word count program in this here in Hive, so simply if we run this this query, we can able to perform the word count program. So previously in MapReduce program, if you want to write the word count program, we need to write the mapper and reducer driver class, and we need to write the lot of code, 100 lines of Java code to count the number of words for the word count program. So here simply this query is enough. So here what we are doing means already we created the docs table. From this docs table, I'm going to perform one function. This function means it will be split the words in each line by using this regular expressions. This whatever the word is multiple, if any word is there with the multiple letters, then it will explode. Okay, this is the query we are using for the word count. So here what we are doing means this is the subquery. So here what we are doing means select explode of this thing words and as word from docs table. So from this docs table we are exploding the words. How we are exploding means first we are splitting the each line by this regular expression. These thing explode means what will do means it will be split and yes, explode is the I function cycle. Yes. So what it will do means it will be split the words and it will be convert as a each row. So I will tell one example. So this is the sample line. This is I function. So this thing, how it will be convert this thing I will explain. So first what we are doing means we need to split that line by using this one. So then what we will do means it will be split each word by this regular expression. So now we will get the 4 words. So explode what we will do means these 4 words it will be convert as a each row. So like this it will convert. So these 4 words it will be explode as a each word as a different row. Like this, if you have the suppose 10 lines, each line will have the 4 words. Then that 4 rows it will be convert as a 40 rows it will convert. So like this it will explode. So this function will do that operation. So then what we are doing means based on that one, so we will get the each word. So that word we are trying to count. We are performing the operations count comma count star from this output. So finally what we are doing means we are creating one more table, word underscore count table from this output. So here in Hive, instead of creating the like this, instead of creating the table, instead of creating the table like this, creating the specifying the fields and creating the new table, we can create the table by using the whatever the query is result returning the output. So based on that query output also we can create the table. So we will run and we will see. So this is how we can write the query and the existing table, and based on that one we are performing the group by operations, group by word. So here each word we will get from the explode. So from explode function we will get the each word. So here what we are doing means we are trying to group by common words. If you perform the group by common word, so if it is repeated 4 times, 3 or 4 times, we will get the this comma how many times it is repeated. So like this we will get the output. So we will run this example and we will. This is the full query. So here I am going to create one more table. Automatically word underscore count table will create based on the this word comma counts. These two will come as a field. So we'll check that one. Now if you observe in job tracker, it will be converted as a different stages also. Why means we are performing some subquery and we are performing group by operations, and again we are creating storing data into another table. So in this example, what we are doing means we are writing the query. So we are writing the query on existing table, and we are creating the table based on the existing whatever the output is there. So query output, based on the query output we are creating the table. So for that one we need to use the this as keyword. So if you specify as and up to this one the creating query syntax, and this one writing the query on the existing table. So this query output will be based on this query output, it will create the new table. So this is we are providing as a alias name. So for this full query, we need to specify some alias name. So that is the table. So how we are providing alias name? So for this thing we are providing as a this thing. So for this full query, we need to provide some alias. So that is the table. So for this, just for specify, while running the query, we need to specify some alias name. So that's why only we are this name. This is temporary name. This name it won't get in tables. So for running the query, we need to provide any name. That's why only this table. I think it is performed. Okay. So now if you observe here, I think here we won't get any, okay, here we will get one more table, word underscore count. We'll see what are the, we didn't specify the, what are the fields are there, we didn't specify. If you observe here, so here just we, this is the only create table and table name. Here we didn't specify the, what are the table columns. So whatever the output is coming from this query, so based on that output only, columns also will create automatically. So these are the two columns, word, comma, count. So count we are specifying as a this one, alias name. So that's why we are getting the count. So this is the two fields we are having, word and count. So we'll we will run the query, select star from word underscore count, and I'm going to display only, I think we will have the lot of data. So I'm going to display only 20 things. So here if you observe, so simply we'll get the what is the word and what is the count. Like this we'll get the data. So if you go here, if you observe in MyDB, So we'll have one more table, word count. So here we'll get this one. So by default it will assign some this delimiter. So that's why it is coming as a box. So if you want, we can specify the delimiter while creating table if we want to specify. So this is the word, this is the count. So for that, by default they will maybe I think by default it is space. So that space it is showing as a this box symbol. So this is how we can do the word count logic by using Hive. So previously in MapReduce, if you want to perform the word count operation, so we need to write the mapper, reducer, and driver class, and we need to write a lot of code. So simply in Hive, so we can write the simple query, one line query, and whatever the output is there from that query, we can simply store into another table. So like this, we can create the table by specifying the fields, and by output of the query also we can create the table. So this is the another way of creating the table. So this is the main concept of the Hive. So what will be there means, so meta information, it will be stored in the meta store. So till now, I think if you observe, we are only using the deadbeat database. So internally, whatever the meta information is there, it will be stored into this meta store underscore db. This metastore underscore db, it will store the whatever the meta information. I think next classes I will try to we will configure, and we will install default database. We'll try to configure the MySQL. So we will see that one how we can configure metastore. If you configure MySQL, then we can see the table information, data information, everything we can store into. We can see in the metastore tables. So how we can create the metastore as a MySQL, we can see in the next classes. So till now we are using the DB database. Here one more point is, I think yesterday I explained regarding this DB database. So we can only one user can access. So only for practicing or testing purpose only, we will use this DB database. If we want to, mostly in production environment or in development environment, we will use the any of the RDMS table as a metastore. So here if you observe, here in this folder we have the one metastore, it is created. So now I am going to some other folder. So now I am going okay, here only I will go. Here I am going to con folder. So here we don't have any the metastore underscore db. Now here I am typing the Hive, and here I am going to perform the show tables. Here it won't show any table information. It will show empty. So but we have the tables in the default, and here databases also it won't show. Default is the default one. So whatever the database we created MyDB, it won't show here. Why means for every folder, so it will be metastore, it will create newly. So if you are trying to access the Hive from different folders, then the metastore will be changed for the Derby database. But if you use the any MySQL or any metastore, so then it will be common for the wherever you are running the Hive. So if you're running the so suppose initially you started from the running the Hive from one folder, then you are running from the other folder. In that cases, everywhere we are running the Hive from. So in all cases, it will be same meta information. It will be there in the metastore cases. So if you configure the metastore as Oracle or MySQL, that cases if you are running the Hive prompt from any place, so the metastore will be common for all users. Also, it will be common. But for there be the what is the limitations are, there be we can use for only single user. So that's why only multiple users are trying to access. So they can't access same time. Multiple users can't access the Derby metastore. So that is the limitation in the Derby databases. That's why only wherever we are running the Hive, so that place only it will show the whatever the tables we are creating meta information, that will it will show. Now if you run show tables, it will show the this employee and the employee one, it will show whatever the tables we created previously, that employee and those tables it will show. So uh, this is the difference between the Derby as a metastore and other RDMS as a metastore. So by default, we no need to create any metastore. It will create automatically Derby. So if you want to support for the multiple users, then we need to create our own metastore. So we need to configure any metastore as a MySQL or Oracle. We need to configure. That is the concept of the metastore. Next classes we will see the how we can create the how we can configure MySQL as a metastore. We will see that one. Okay. Okay, till now we are running the each query individually. So we are running the we are going to Hive prompt and we are running the Hive queries. So instead of that one, if you want to write all the queries in one file, how we can run it? So executing the Hive script. Hive script is nothing but we will run the what are the queries are there. So we will copy into one file and we will run the, instead of running the single query, we can run the all the queries. If you submit this file, automatically it will run the one by query it will run. So we will see simply what are the queries if we want to run. So all the queries we will copy into one folder, one file, and we will run as a like this Hive space -f space file name. We will see so if you want to practice the Hive scripts, all queries will be there in the this path home tiny / Hive scripts. We already having some Hive scripts, so you can run it. So what will be there in the this SQL this file? So we can give any extension. We no need to give the .SQL. We can give .HQL. We can give any extension. So that is no problem. So simply we need to create one file, and there we are specifying the drop database, create database, use documents database, create table. So whatever the operations we performed previously, those operations we are performing. All the queries we copied into one file, and we are trying to execute the we need to run execute as a one file. So that one simply we can run like this. If you want to run the all the queries as a file, so then we can use the option -f. So we'll go through this one. Okay. So simply if you execute this one, all the queries, it will be one by one query, it will be run automatically. 1 minute. I think maybe file is not there. We'll check that. or maybe this folder name wrong. Hive script folder name. Then file name is wordcount.stl. Okay, this name is correct. Okay. So if you submit automatically, it will run as a different program. So if you observe here, so everything first it is created the database. That's why only it is showing okay time taken. Then it is copying, trying to copy the file. Now then it is trying to run the this query. Whatever the query, this query select star from word count limit. So that query is trying to running. So this is it is trying to display under records. So word on count. So previously this word count only. So by using script file, so we are running like this. So whatever the queries are needed for the single task, we can write here and we can execute as a Hive space -f and we can able to run. So here if you go inside the Hive and if you check the database, whatever the database we are specifying in the this script file, this database will be there. This database will be there and this table docs and the other word underscore count it will be there. So I think why we are using databases, I think you got the point, I think. So here we are using same names, this docs and word count. Already we have the, we created these two tables, but we created in the some other database, MyDB. Now we are created in the other database, documents database. Show databases. So here we have the documents database. We can use that one. Use documents. Here if you go inside show table, you will have the two tables. So docs and the word counts table. So if you go, if you can see these things in the HDFS also. HDFS will, documents.db will be created. You have the two tables. So like this word count and this one. So like this we'll have the two things. So like this we can create different databases and different tables, and like this we can create the tables. We can load the data. Once if you are trying to execute the query, then it will convert as a MapReduce program and it will display the results. So if that program needs multiple programs, it will be converted as a multiple MapReduce programs. Then it will be converted as a different stages. I use stage 1, I use stage 2, like this it will convert. Okay, this is how we can create the tables. Next we have the one concept called schema. Schema, not schema. Metastore is not similar to schema. So Metastore will have the information about the all the tables. So here what we are doing means, here we are in Hive we are creating the tables, and whatever the data we loaded into HDFS we are trying to fetch using the this one queries only we are doing. But data, where it will be data will be there. For all the data what are we are storing, it will be data, it will be under these tables only, this data will be there. So if you want to, so now if you after creating the tables, loading the table, loading the data into tables, so we need to fire the queries. So while firing the queries, we need to maintain the this table information, column information. those information we are creating into Metastore. So that is about the Metastore. So those will have the information about the tables, information about the database, so information about the each table columns, and next I will tell the partition concept. So those information it will be stored into Metastore. That is the Metastore. So all the information related to the Hive tables, Hive partitions, Hive columns, and Hive databases, that will be in the Hive Metastore. So tomorrow I will show the we will create the MySQL. Then you will get the clear picture. What will store the Metastore? How the Metastore tables will be there? What are the information will be there? You will get full clarity on tomorrow. Okay. Till now, if you observe, so we have the employee table. So till now, whatever the data is there, we are loading under single table only. So it will be suppose if I have the 1 year data. So if I have the 1 year data, I need to load under this table. So if you want to write any query, if you want to find anything, it needs to be search on the full 1 year data. So instead of that one, in Hive is providing one concept called partitioning. Partitioning means instead of suppose if you write the one query, it will search for the 1 year data. Instead of that one, if you separate the data as a month, or if you separate the data as a date every day, so then if you want to search the instead of searching the full year data, so we can file the queries on the particular day partition or particular month partition kind of things we can do it. So how we can do it, we will see. So for that one, if you want to create like that, we'll see the query. So we have one more script file called partition, using partition. So I'm going to create one table, wiki sample. So here I specified the previously how we can specify. I specified the 4 column. This is the column separated, how we can split the data. And here one more keyword I'm going to add, partition by. So based on which field we need to partition, that field we need to specify. Here I'm going to partition the wiki data by using the project name. Maybe either it will be English language data, or maybe it will be French language data. Like that, I'm going to split using this name, project name. So if we store the data, while storing the data also we need to specify the under which partition we need to load the data. So that thing also we need to specify. Previously what we are doing means simply we are loading the data into table. Now what we are doing means we need to specify the under which partition we are going to load the data. So this is the example, simple example. Later we will see the how we can load the uh, different logs data. We can see that one, how we can create the partitions on the day wise or month wise. If we want, how we can create, we can see that one. So for your understanding, so here we are creating one partition table with the project name. So unloading, we are loading the data with the under this partition, en partition. We are trying to load the data. So coming to how the data it is there, so we'll see that one. CD wiki sample. So here we have the different data. So this is the en project data. So this is the how we will have the only project name with en only it will be there. So like that we will have the So like this, we'll have the separate data. So EM project data, French language kind of websites data. So this information, what is this information? This is project name, this is the page name, the number of hits, and this is the size of the page. So like this, we have the different fields. So for that, we created the project name, page name. We created the 4 fields: page count and page size, and we are trying to load the data by using particular partition. Now we will try to execute that one, and we will see. Using partition. I think internally it will have some errors. We'll check that one. I think maybe query syntax wrong. We'll try to run execute again. Okay. Okay. Here end of the thing, if you observe here, one number of partitions equal to 1, number of files equal to 1. So if the data is executed successfully, then we can see the like this number of partitions equal to 1. We'll go through inside Hive and we can see the table. Show tables. So here we have the wiki sample. So we can see what are the fields are there. Describe wiki sample. So we have this one. So these are the fields we have. This is the partition field. What are the partition is there? It will come as a last field. It will come project name. Okay, if you go through this one, wiki sample. Here if you observe, previously full data, whatever we are storing under employee, so it is like this, it is storing. So it will be, if, suppose if I want to store 2 files, all files are storing under the employee table only. But now what we are doing means, under wiki sample, we created the one partition. So partition is nothing but a subfolder. So whatever we are providing field name and field value will come as a partition folder name. Inside that one, this data it will be there. Like this, it will be data. It will be there. Now I am going to create one more partition. So how we can do it? We will see. So simply, I am going to run this command. Before going to that one, we will change the partition names. We will change this data name fn, fr, and the project name as a fr. So simply already table is executed. Table is created. So data also one partition created with the en. Now I am going to create one more partition. So here if you observe, number of partitions are increased to 2. Number of files are 2. So total size also it will be displayed. So here if you go here, so here like this, the different partitions will come this. So first project information will be in first partition, second partition will become as a second partition. So like this we'll have the we can create the different partitions. So what is the advantage of this partitions means? So instead of storing the full whatever the information is there, instead of storing under the single place, we can split as a partitions. So we can Suppose if I have the 1 year data, I can split as every month data separately. In that month, we can specify the sub partition as a day also we can provide. In that day also, if you want, we can provide the hour also we can specify. Like that, we can specify the number of partitions we can specify. So this is by using these partitions, we can easily add the one more partitions without disturbing the existing data. We can create the one more partitions. We can, if we want, we can create the existing partition also. We can delete the partitions. So suppose if I have the 10 years data, so I don't want the last. Suppose if I have the data of the 2001 to 2014. So now I don't want the old data. Suppose if I want to delete the old partition, 2001 partitions, so I can delete easily. So without disturbing the table, without changing any table, other users can access on the other partitions. And if you want, we can drop the old data also. We can drop the data. So that is the advantage of this partition. So by using these partitions, we can separate the whatever the data we are going to store into table. We can create the separate partitions. We can create the data underscore that partitions. We can do it. So this is how we can create the partition. This is the advantage of the partition.
Okay, we will look on that too.
So yes, like staging table only, Shekhar. So here till now what we are doing means we are doing only static partition. Dynamic partition means first we will load the full data into one table, and that table will have the all 10 years data, and another table we will have the partitions table. If we move this 10 years data table to the partition table, automatically I will have the differentiate the different years data, and it will create the 10 folders, 10 partitions for the 10 years data. Like that, it will be create. That partition we will call it as a dynamic partition. So whatever we are doing till now, it is the static partition. So if we want to create the dynamic partitions, we need to set some properties in the Hive. So what are the properties we need to set, and how we can perform the dynamic partitions? Tomorrow look into that one. So this is the one more feature, a main feature in the this one Hive. This is the partition is the one good feature in the Hive. So by using this one, we can split the data as a different partitions. If we want to create separate partition, we can create partition and we can load the data. And if we want to drop that partitions, we can also drop the partitions. So we will see how we can drop the partition. So now I'm going to delete this partition, project underscore name partition. So for that one, this is the syntax: alter table, table name, drop partition, and we need to specify the what is the partition name. So once we executed this thing, so this partition will be deleted. So it will be deleted from the HDFS, and it will be deleted from the Metastore also. It will delete the data. So this is the dropping partition. Like that, we can, if you want to drop the table, we can drop the full table. If you want to drop particular partition, we can drop the partition. So by using this partition, suppose if you want to, without disturbing the table, if you want to drop the old partitions, old data, if you don't want, we can delete the, simply drop the old partitions. This is the one of the advantage of this partition. Simply we can add the partitions, we can drop the table. This is the syntax for the table, drop the table. Like this, if you want to add the partition manually, so we can add by using alter table wiki. We can add the add partition also. We will have the option, so we can add. Like this, we'll have the different command. So tomorrow we'll see what are the different commands. Other add and drop. I will show that comments also. I will show those queries also. Okay, this is about the simple how we can execute the Hive queries, how it will be converted as a map redis, what is the partition, and how the data will be splitting as a partitions. These are the things. So tomorrow we'll see other concept, dynamic partitions, how we'll configure as a MySQL as a metastore, and we'll see some other concepts. Okay, thank you all. We'll see you tomorrow.